Welcome to homework.
We're given 0.735 molar weak acid, and then it's also given is around 12.5% dissociated. So what would be the concentration of hydronium, pH, hydroxide, and also pOH of the solution? And then for part two, we also have to find out the Ka of the solution. So first of all, let's write out the acid dissociation reaction. So we have a water, and then we dissociate to form hydronium ion, and also the conjugate base. So you are going to set the ice table. Since we start with 0.735, so we put it under our acid. We don't care about water, and then we have roughly around 0 hydronium and also 0 molar of A minus. And the change is we're minus X, we're plus X, and also we're plus X on the right. And then at the equilibrium concentration, you're 0.735 minus X, and then we're X and X for our hydronium and also the conjugate base. So the Ka of the weak acid can be found by multiplying the equilibrium concentration of our acetic acid and also our the conjugate base and also the hydronium over the concentration of our acid. All right. So and we are given the percentage dissociation is 12.5, and this dissociation is calculated from the amount of acids being dissociated, which is also equals to the concentration of our conjugate base over our original concentration of acid times 100%. So therefore, the concentration of our conjugate base should be equals to our original concentration times the percentage. We got to tell you only 12.5% of the original concentration dissociate, and all those acids will give they will give our conjugate base. So therefore, we are going to take our initial concentration multiplied by 0.12, which is corresponding to 0.125, which is corresponding to the percentage 12.5. So 7.735 times 0.125. And then we will have the concentration equals to 0.0919 molar for our conjugate base, or A minus the ion. All right, so when we go back to our ice table, essentially you find that the concentration of our anion is equal to X. So in other words, so this value will be our X. So, okay, so when we have the concentration of our conjugate base, so we can find the concentration of hydronium because, again, they have the same concentration. So the hydronium concentration also equals to 0.0919, so it also equals to the concentration of hydronium. Okay, so for pH, we just need to take a negative log of our number. So pH equals to log of our concentration of hydronium ion, so it equals to 0.0919. So we take a left log number of it, so it will be equals to 1.04. Okay, so this will be pH. So we have hydrogen and pH done. Okay, the next step will be the concentration of hydroxide ion. Okay, so first of all, the pH plus pOH equals to 14. So pOH will be equals to our 14 subtracted by the pH. So we have 14 subtracted by the pH 1.04. We should be able to find that the pH is roughly around 13.0. 30.0. Sorry, that's 12.96. 12.96. So we are looking at the least decimal place. We're not going to do subtraction. So we're going to 12.96. Okay, so this will be our pH, and the concentration of our hydroxide ion will be equals to 10 to the minus of the pOH. And then we are going to take our 10 to the negative power of negative 12.96, and then we should be able to find that the concentration of hydroxide ion should be equals to 1.10 times 10 to the power negative 13. Okay, so we have a hydroxide soft and also pOH soft. Okay, the sand step will be our Ka. So we are going to move this expression to same page. So we know Ka equals to x squared. We have a 0.735 minus x. And then at the same time, we know that x should be equals to 0.0919. 0.0919. So, and then we are going to plug in our equation over here, and then we can solve for Ka. So we have 0.0919 squared divided by 735 minus 0.0919. And then at the end of the day, we should be able to find that is equal to 0.0131 for the K value.